Okay, it looks like it is the appointed hour. So welcome everybody to the next installment of the Aircraft Ecosystem Working Group. My name is Carl Russell. I'm the lead for this particular working group, and today's topic is automated flight and contingency management and the RFI that has gone out on that. A couple of housekeeping items that I want to remind everybody of. One is that we are recording this session. The recording, if and when it's approved for public release, will be made available in about a week on the NARI website. Another thing I want to ask people is if you are not the one speaking or one of our active participants at the moment, please leave your camera off, and that'll help us conserve bandwidth on the meeting. And also make sure that your microphones are muted so that we don't hear any wonderful background noise or feedback. I think that's all I have for kind of opening remarks. I'll just kind of go over to the presentation here. And so here's our agenda. So just a couple of introductory remarks here. Then I'm going to introduce Ken Goodrich, who will be our main presenter for today, giving the overview on the AFCM project and the RFI. And then we will move over to discussion. We've split the time up to be about 50-50 between the presentation and the discussion. So hopefully we'll have a lot of good questions from the audience and can get some good discussion in. And then we'll wrap things up. Should be about 90 minutes total. But if things end up running a little bit shorter, we'll give folks a little bit extra time back on their Friday. So away we go. All right. So I want to introduce Ken Goodrich, who's probably familiar to a lot of you. Ken is the Deputy PM for Technology for the Advanced Air Mobility Project. He sits at Langley Research Center. And I think with that, Ken, I will turn it over to you, and I'll stop sharing. And then you can, oops, what did I do? I need to go to my other screen here.
All right. Thank you, Carl. Can you confirm that you're seeing my my titles fine?
Yep.
All right, great. Let me echo Carl and thanking folks for joining us either Friday afternoon or morning, depending on where you are. I know I saw a lot of familiar names coming into the meeting room. It's probably only going to take me about 30 minutes to go through the package. So we'll have plenty of time for Q&A, and I'm looking forward to interacting with folks. Also during the Q&A, I'll be joined by Murray Stringer, who is the sub-project manager for the Automated Flight and Contingency Management sub-project in AAM, along with Mary's at Langley, and we'll also be joined, I believe, by Mike Fury, who is the tech lead for AFCM. He's at Ames. So with that, let me go ahead and launch into the package. So the goals for the session today, we want to give folks a overview of what NASA is planning for the automated flight and contingency management area, specifically focused on urban air mobility. There's actually a couple of projects that have latched on to the AFCM name, but have various applications. Today, this will be focused on that urban mission. Then we'll give a description of the partnership strategy that's developing, including briefly touching on the current RFI. Hopefully people have seen that online. I apologize for not being able to do this session earlier. The RFI has been out since mid-July and closes August 18th, I think it is. So there's about a week left to be able to respond to that. And then the final item for the day is to be able to answer questions from our participants. So just a little bit of brief background. I think most people, if you're regular participants in these working groups, you're familiar with the idea of NASA's critical commitment in the AAM area. It's basically to define an overall system architecture and corresponding set of requirements and interfaces that moves the community towards this UML4 operating capability. I'll touch briefly on UML4 in a moment. But with this overall system architecture, it's important to recognize that includes a vehicle segment, where that vehicle includes both the development of the base vehicle as well as how it operates in the environment. Most of what we'll be talking about today focuses on that operational aspect and how those operations are supported by automation and probably in the near term a human automation team. The other important elements of the architecture are the airspace system design and how it operates. And of course, the vehicle automation is a significant part of that airspace system architecture. And then the third element being community integration. And particularly important areas there is considering vertiport integration into the local community. Things like obstacle clearance surfaces, safety setbacks are very important to how we go about doing that. Of course, vehicle automation plays a significant role in determining those factors. So the vehicle automation and operation very much touches all three of the elements in this system architecture. So I mentioned maturity level 4. This is where the urban air mobility system really is at a level where it can begin to scale and provide routine operations in cities around the world. So at the level of individual cities, UML4, this is sort of a rule of thumb or we're talking about hundreds of aircraft aloft over a given metro area. That's a lot of aircraft compared to what we're used to thinking in terms of for traditional aviation, but it's still on average medium traffic density, although you could imagine in the vicinity of key vertiports or nodes in that network that the traffic around those areas is going to become quite dense. Thinking in terms of an urban area, there's probably on the order of tens of vertiports. Some of those, in the very high demand locations at the commercial airport in that urban area, there's probably going to need to be some sort of rigorous slot management. And again, this gets into interplay between the vehicle and the airspace automation. Vehicles are probably going to have to follow some sort of rigorous slot management strategy. So being able to accurately execute 4D clearances is probably going to be an important part of UML4 operations. So moving away from that medium density and on to medium complexity, to be impactful in densely populated areas, we need to be able to operate in close proximity to people and property. So this means there's going to be limited setbacks or physical separations from the vehicle operations, where the vertiports are sited in the community, and where people and property are situated around those. So it requires a very reliable type of operation with the ability to have successful contingency plans that can be implemented that effectively eliminate or certainly minimize the potential for any sort of forced landing that doesn't take place at a designated vertiport or at a minimum, some sort of emergency landing area. Along with these medium complexity operations is transitioning from visual operations in VM to be able to get into IMC operations, whether we get all the way to visibility independent, zero visibility versus higher levels of visibility. I think this is an interesting research question, and I think the answer to that is going to come looking at the combination of sensors which are not impacted by low visibility conditions, combined with the operational benefit that can come with driving visibility requirements from the traditional ILS levels of 200 feet down lower and lower. So I think that's a trade that's going to be an important part of the AFCM activity. And then the third main bullet is getting into what we call collaborative and responsible automation systems. And these are very much at the core of the automated flight and contingency management sub-project. The first sub-bullet here, talking about responsible automation. This is where we have the ability to automate a function with sufficient reliability that it is completely removed from the pilot's responsibility from performing. So they don't have to learn how to do it initially. They don't have to monitor it during the operation, and they don't have to be prepared to backstop it. So this is very different from traditional automation, and is one of the key things that makes the AFCM objectives for UAM different than traditional automation. Traditional automation, there's a lot of benefit in terms of safety, performance, in terms of things like low flight technical error combined with workload relief for the crew, but almost all of the automation functions on the flight deck of a commercial aircraft are allowed to fail, and the pilots are expected to be able to complete that mission using traditional piloting skills. If we have in UAM a situation where the automation is allowed to fail and the pilot has to be able to back it up, we're really not getting any benefit from a training or simplified piloting perspective. And one of the significant goals here is to be able to reduce the amount of specialized training and experience that's required to be a safe and efficient UAM pilot. Along with responsible automation is the idea of collaborative automation. This is the vehicle having sufficient, I'll use the term situational awareness, to be able to understand what's happening around it. At a minimum, being able to highlight emerging threats, being able to help the pilot identify those and come up with appropriate mitigation strategies, while at the same time efficiently executing the nominal flight. And I should say, when we use the term automated flight and contingency management, that includes both the appropriate conduct of the nominal mission, as well as preparing for and having plans ready to execute in contingency situations. So again, if people have been following along with these working groups, you're probably familiar with the NASA Pentacopter showing the pillars. And so just let me highlight that when we're talking about automated flight and contingency management, we're talking about things that are central to what we call Pillar 2, which is the individual vehicle management and operations. So this includes safe urban flight management, how do you operate in this very complex environment? Hazards are probably much closer than they are for traditional aviation. Wind fields, for example, may be more complex. The potential to do contingency landings, they're actually closer in time than traditional aviation, but there are limited areas where they can be performed in the urban terrain. Key thing is increasingly automated vehicle operations. And this is motivated by increasing the scalability of the system in terms of reducing the specialized skills and knowledge required to be a pilot. And I should say, when I'm using the term pilot, at the UML4 level, we still expect there to be a dedicated pilot in command for each vehicle, but that pilot may be on or off board. So we're looking at both on and remote piloting in the context of AFCM, along with simplifying that process of becoming a pilot. The increasingly automated operations is simply important to providing the task performance and precision required of UAM. Third bullet here, getting into the certification and operational approval. People have been demonstrating advanced automation support for pilots for decades. One of the key challenges, though, is challenges, I should be saying plural, is a combination of being able to show it can be implemented with the reliability that is required for the pilots to really be able to rely on it, or more importantly, is that being recognized in the certification and operational approval process, not just on the vehicle side in terms of the airworthiness of the vehicle, but also being able to get appropriate credit for the automation assistance from a pilot training perspective. So we want to be able to influence both the airworthiness certification process as well as the pilot training and qualification elements that are defined, for example, in Part 61 and Part 135 for commercial operations. And then the final aspect of this pillar, too, is being able to support those overall UML4 operations that I touched on earlier. So, key thing here, the real focus of the research area is looking at the combination of the automation and the human contributions to that, and being able to simultaneously achieve collaborative and responsible automation along with those overall UML4 operating capabilities. I want to highlight that this is a broader area than just thinking in terms of the automation technology. I tend to view this as there being 4 major puzzle pieces to being successful in this area. First is developing and understanding the operational environment for UAM. We're talking about having to develop flight procedures that are appropriate for these vehicles with novel flight characteristics, operating in a novel area. That is, of course, is combined with the automation and the underlying aircraft system. And let me just take a moment to talk about the importance of the basic aircraft system. A significant part of being able to have robust contingency operations is designing the base aircraft to have fail operational capability. So no first failure, for example, should leave the aircraft in a situation where you don't have a known and safe level of flight performance. Over on the lower left side of the puzzle is getting into the human system integration. At UML4, as I mentioned earlier, we're still looking to have a pilot in command, but also at the same time looking at the future scalability of the system to where there is in command for each vehicle. And then finally, the lower right piece of the puzzle is looking at the safety and certification process for the overall vehicle operator and flight operation. So looking at the interaction of those three elements and achieving an outcome with an appropriate level of safety for urban operation. So at the project level, things that AFCM is chartered to develop includes developing proof of concepts, which includes the aircraft automation, the pilot vehicle interface, and the flight operations integrated with those. The overall, looking at the overall UAM system of requirements, focused on the aircraft automation aspects of that, the flight operations, and where those two elements have interfaces to the external elements of the system. So, for example, the broader airspace system, as well as elements of vertiport automation. Third item here is looking at developing reference aircraft automation architectures that can be used to illustrate things like mock certification processes. The industry members developing actual commercial hardware can learn from and advance on. Fourth item here is that integrated framework that I mentioned that's so critical, which is being able to develop a appropriate set of standards that allow for the certification of the human automation system with appropriate requirements for both classes of agents. And then the final item on this chart is just facilitating that path to increasing scalability. We want to get to UML4, while at the same time introducing technologies that allow us to continue to the 5 and 6 level. So just giving folks sort of a view of this. This chart's probably too busy. But it sort of provides a mental map of how we're viewing the AFCM area within NASA, how it fits between the base aircraft. I should point out that some important parts of the automation, for example, the inner loop flight and propulsion system, those are actually the RVOT project has the charter for those. But as I mentioned, where they define things like the minimum level of vehicle performance following first critical failure, they very much, there's a joint or shared responsibility between AFCM and the developers of those base vehicle technologies to be able to understand the interplay between them. At the upper side of this chart is showing how the vehicle is a participant in this broader airspace system. In particular, the flight procedures are a key touch point between the vehicle automation, and the broader airspace system. And then looking in the middle here is sort of the key functional elements of automated flight and contingency management. So thinking in terms of the timescales of these operations, at a strategic level, AFCM is engaged in things like mission management. There's probably an operations control center that's deciding possible origin and destination options for the flight. Along with that, the vehicle needs to be keeping aware of possible divert options in the event of the nominal destination becoming unavailable, as well as contingency plans that would be enacted should particular vehicle failures occur. Along with that mission management perspective is strategic flight path management. And this is just a way of saying for the given mission that's being executed, doing that in an efficient or optimal fashion. So at this level, there's probably ATM interaction that's being supported by the automation, as well as, for example, route optimization. Moving down in shorter time scales, we get into the tactical realm. This is where a maneuver might be required that doesn't impact the overall strategic plan. But in terms of safety of flight, this is an area where safety of flight really starts to become important. So first thing is having awareness of what's going on outside the vehicle. So this involves first being able to sense, to detect or perceive what is in close proximity to the vehicle, forming that into an integrated sense of situation awareness, and then being able to appropriately identify and resolve conflicts to the safe execution of the flight. And then getting into the shortest time scale that AFCM is working on is what we'll term the vehicle control layer. This gets into auto flight or an auto flight system if the vehicle is being operated in a coupled fashion. Simplified handling gets into if the pilot is, I'll say, manually commanding the trajectory. It's important to understand when we talk about manual control of a vehicle like this, there really isn't any equivalent to manual control in terms of direct stick to surface interaction. The simplified handling is always going through some sort of a flight control computer, and the vehicle is commanding the actions of the vehicle rather than manually controlling them. And then down at the lowest level of vehicle control are various potential safety nets. You could think of these as reflexive protective behaviors. So could be things like envelope protection or protection against imminent external hazards, collisions with another vehicle or terrain, for example. And then finally, on the left side of the chart, just shows how these functions typically map against current today's aircraft. Don't interpret this as reflective of the sorts of interfaces that we expect to have on these urban vehicles. So in terms of the AFCM area, our strategy and our timeline is synchronized with the national campaign series. And again, I expect that most of the people on the call today are familiar with that, but I just want to take a couple of slides to make sure everybody is on the same page and talk about what that means from an AFCM perspective. So from the present through 2028, there's nominally 4 of these events scheduled. It's important to recognize that the further we go out in time, the more notional these become. We want to be able to be agile and take advantage of what we learn along the way. So these later events certainly aren't cut in stone. The first activity, well, let me just briefly highlight these. NC1, which nominally is scheduled to occur in FY22 as sort of an exploratory activity, bringing the community together, both from a vehicle perspective and an airspace management perspective, and evaluating the ability to perform a set of baseline scenarios. The other NC events start to build towards a unified concept of operation and architecture across the system, building first on NC2, what we call complex operations. which is sort of looking at the elemental elements of how the vehicle would operate and how the airspace system would manage those operations. I'll talk a little bit more about that on a later slide. Moving from those building block elements to NC3, putting the building blocks together to show how they enable high volume vertiport operations, both in nominal situations as well as being able to handle disruptions and contingencies, both from a vehicle perspective as well as an airspace perspective. And then finally, NC4 is showing the ability to operate at that UML4 level. So the overall objective of both the series as well as the AFCM sub-project is helping the community to move forward faster than it would be able to on its own. So, fundamental objectives include accelerating the certification and approval process, developing flight procedure guidelines, developing and interfacing with appropriate comm, nav, and surveillance infrastructure for urban operations, developing an appropriate airspace operations management architecture from the vehicle perspective, developing how the vehicles participate as part of that architecture. And then finally, the fifth element is identifying and helping to mitigate community concerns. From an AFCM perspective, that probably includes primarily a combination of safety, both from the perspective of passengers as well as persons on the ground, as well as passenger acceptance. You can think of that in terms of ride quality, being a combination of the vehicle augmentation combined with the sorts of flight procedures that the vehicle will be operating with. So those national campaign events nominally occur every other year. They're complemented by what we call integration of automated systems flight testings, which occur in the between years. So it's easy for me to keep this mentally by remembering the NC events are even years, the IASs are odd years. And the IASs provide the opportunity to do structured flight evaluations of the system elements as they're being developed. So from an AFCM perspective, the first major flight opportunity coming up is in the 2023 timeframe. Then in 2025, looking at extending that capability to demonstrate high volume vertiport operations. And then 2027, getting into the system-wide demonstration. So just for the sake of the conversation today, let me highlight that first so-called complex operations. And what I want to draw people's attention to on the chart are the areas in yellow. And these are sort of the building blocks from an automation perspective that we intend to focus on initially. So includes, as I mentioned, both nominal operations as well as being able to do decision-making and execution for contingency situations. From a nominal operational perspective, key things are how we interface with the airspace system. So things like time-based trajectory operations will probably be a key part of the airspace system architecture. So we need to develop, characterize, and validate the aircraft's ability to perform those. Along with those time-based operations, there's probably some aspect of airborne detect and avoid or detect and follow if we're talking about managing in-trail separation. So that's an area of interest. Contingency management, examples that we intend to look at there for complex operations would be things like if the nominal destination closes, what are your divert operations? If the battery packs on the vehicle, if you have a sudden unexpected loss of one of those packs, what divert vertiports are within range to go to. Hazard perception and avoidance. I want to highlight operating in these urban areas, the proximity to hazards and the potential for uncharted hazards is much greater than for traditional aviation. So having the ability for the vehicle to perceive directly, as well as using that capability to make the pilot aware of these dynamic hazards is very important to the efficiency and safety of UAM. So bringing these, evaluating different ways of performing these operations and working on the integration of them is a near-term focus for the AFCM sub-project. So just showing this in sort of a conceptual system diagram. This is drawn from something of a NASA-centric position or perspective. The acronyms over here on the right side of the chart correspond to various NASA project activities that are developing relevant constituent technologies. Let me focus for this audience primarily on the left side of this chart, which is the core blue area showing a notional vehicle architecture. The way we're structuring the overall AFCM area, there's basically two primary components to it. One we're calling automation-enabled pilots. The second is assured vehicle automation. And let me just briefly explain the charters between these two activities. It's very much a combination of the two required to be successful, the overall automated flight and contingency management. But the AEP element has the lead for looking at the human automation interface aspects. The near-term things that they're focusing on include simplified handling and operations of the vehicle. So this includes the intersection of things like the flight dynamics, the manual control inceptors, as well as the flight displays and the flight procedures for UAM operations. That is combined with enhanced displays and interfaces to the broader automation system, as well as looking at the impact that these automation additions have on the pilot requirements or qualifications. The assured vehicle automation aspect focuses on the down and in of the vehicle system, and the functions as illustrated on this chart correspond to those levels that I talked about previously on the earlier chart, starting at more strategic decision to support, getting into local perception and situational awareness, and then the actual conduct of the flight. So moving from higher level automation or autonomy of perception and judgment, which is probably going to be performed by a combination of the human automation team, getting down at the lower levels into autonomy of execution. The big blue area here is focused on the perspective of a single vehicle. I just want to emphasize that, of course, this is operating in the context of a broader airspace system. So there's vehicle-to-vehicle interactions taking place, coordination. There's activities with the fleet operator who's looking at managing their suite of vehicles. And that also is then combined with interactions with the broader airspace system, and then vertiports within the broader context of that system. So in terms of going back to this timeline chart, we have activities that are already starting, both from the perspective of automation-enabled pilots, as well as that down and in-vehicle automation perspective. Nominally, these two areas are known as simplified handling and operations. And then the more integrated concept of looking at the UML 3.4 sorts of capabilities is focused on initially developing and evaluating those technologies in the context building up to the first flight opportunity in 2023. And then going on beyond that, sort of these two lanes of research become integrated. And at that point, we're looking at an overall integrated solution to enabling those UML4 operations. So sort of changing gears, that's the background on the NASA activity. Let me just briefly talk some about the request for information that's out there, and then also the overall partnership strategy. I want to emphasize that the RFI is open to any organization. We want to hear the input from the broader community, what areas you think are high priorities, where you think solutions may exist. We're particularly interested in getting responses from organizations that are actively developing component level technologies, integrated flight systems, and integration onto flight vehicles. Those are the people that we're probably going to be looking at partnering with down the road to help both mature the technologies. Then from NASA's perspective, we're not so much about developing specific technologies as we are developing that certification and approval framework. But it takes a combination of both industry working on their specific things combined with NASA's ability to conduct analysis and research from a broader perspective to be able to enable the development of the standards and guidelines that are necessary for the technologies to be able to smoothly certified and approved for operation. The RFI has suggested responses. Don't feel that you're limited to those. We definitely appreciate your candid responses. So it's your opportunity to give unfiltered feedback to NASA. Of course, as part of all this, any information that you identify as proprietary is treated as such and is protected from any sort of release. And then as you're going through this, you might want to consider NASA facilities or capabilities that would be of interest to your organization if you are considering a partnership. And my slide package will be available on the NARI website, so you can look for this there. But this just shows some of the facilities that might be of interest to people who are either developing integrated systems or looking at the vehicle integration aspects. And then finally here, from a partnership perspective, these are sort of our broader stakeholders. These are the people that are actively engaged or manage the process of helping to develop those guidelines, policies, certification, means of compliance. Folks that we would probably work with more directly include vehicle developers, and these may be people that are already developing an eVTOL aircraft, or they may be folks that are doing longer lead development using some sort of surrogate platform, particularly people who are focusing on the development of the automation, often are using more conventional helicopters or fixed wing aircraft to integrate and evaluate those automation capabilities. The avionics companies of the world, people who are working on integrated panels, so the perspective of the pilot vehicle interfaces, as well as the integrated systems that need to be behind that panel. And then finally, technology developers. Things of particular interest here include sensors for the external awareness, the detect and avoid aspect of the problem. So the engagement strategy, we're engaging with the community. This is part of that outreach activity. We have the RFI that is out on the street. Responses from that are due in roughly a week. We will use that information to help shape the formulation of our project. We have a significant review coming up in mid-September. And then based on the combination of those two things, we will be developing a announcement of collaborative opportunity. You've probably seen those in the context of the earlier NC events. We expect to have another round of those coming out in the January timeframe. We expect there to be an opportunity to talk about details of collaboration for AFCM in the mid-January timeframe, and then nominally industry would have on the order of 2 months to respond to that. And from those inputs, then we would get into the negotiation of Space Act agreements to have an actual partnership in place. So with that, that's the end of my presentation. So, Carl, I think we're ready to transition to the Q&A session.
All right, excellent. Thanks, Ken. And let me just give me a second here, and I'll move over to the slide where I've got some of the kind of how we're running the discussion here. So let's just do
all right. And I'm gonna. Okay, you took the screen.
And there we go. And so now you ought to see platform and discussion, hopefully. And let's see here. So, hopefully people have kind of already seen the kind of the ground rules of how we're doing this here. Basically, let's make this full screen. There we go. So basically, we have kind of two different ways for you to give feedback and ask questions here. We have folks who are on the Microsoft Teams meeting right now. And so if you want to kind of speak and or ask a question, just type request to speak in here in the chat box, or you can also type your question there, and I'll probably just call on you and ask you to kind of either repeat your question or maybe expound on it a little bit. Just make sure you just say who you are, where you're from, just so we know who we're talking to, and try and limit your speaking to about 90 seconds or so. I'm not running a stopwatch or anything like that, but just so we can make sure we get in as much or as many responses as we can. The other option is if you're just watching the YouTube live stream, you can go to the Conferences.io page and you can ask a question there. We are kind of prioritizing the ones that are in the active participant list, but if we run out of questions there, or if we see something really interesting over in the Conferences.io page, we'll go there. So it looks like we already have a couple of questions here in the chat, and so let's go to Sean Calhoun's question. Sean, if you want to kind of unmute yourself and say hello and ask your question here.
Okay, can you hear me okay?
We can.
Yeah, you're loud and clear.
Thanks, Carl. Thanks, Ken. Yeah, I got a question. Sean Calhoun from Cal Analytics. Can you talk a little bit about when it comes time for the ACO in January? Are you guys looking for kind of end-to-end teams that small groups or technology developers would have to kind of partner up with vehicle manufacturers and OEMs, or is that something that individual companies can respond to, and NASA is going to try to kind of pull the various pieces together?
Yeah, so that's a great question. And having been a participant of earlier small aircraft programs, if people remember back to the Agate or the SATS program, that involved a large amount of partnering. So a lot of experience from managing that. So I think, Sean, not to ramble too much on your question, some of that is going to depend on the RFI responses that we get back and the range of those. Certainly from NASA's perspective, it's easier to manage if teams sort of form behind the scenes and then interface with us as an integrated whole. And certainly one of our key objectives is to be able to move things quickly through, the development process. And that moves much quicker, right? If you have a combination of the technology developers, the flight system integrators, and ultimately the airframers who would certify that as part of the aircraft working as an integrated whole. So if there's a good way to achieve that, I think that's the optimum situation from NASA's perspective. But obviously that puts a lot of complexity on the other side of the interface.
All right, thank you.
All right, excellent. Moving on down the list here, looks like we have a question or a comment from Jim Williams. So Jim, you can unmute and we'll hear from you.
Yeah, this is Jim Williams. I'm working with Aura Network Systems, and we provide connectivity for aircraft. We're a startup, just got the spectrum going, and we're curious as to if any of this work would involve connectivity between the UA and the ground, or between UA to UA, and so consequently trying to make a determination whether we should submit a response to the RFI.
Yeah, so funny you should ask this question, Jim. I mean, this is a critically important area to this system. Being efficient is having appropriate connectivity between air and ground and air to air. How exactly to do that in the urban environment with all the spectrum limitations that are out there, as well as heavily utilized spectrum in urban areas, combined with the challenges of just a lot of signal blockage and multipath. So yeah, this CNS is an important area, and please do respond to the RFI.
Will do. Thank you.
All right, thanks, Jim. Let's see. Looks like our next question here is from Brandon Suarez. Brandon, if you want to unmute and you can ask your question.
Brandon, okay, sorry, go ahead.
I was just going to say he's also typed his question here, so.
Oh,
yep, go ahead.
Sorry, I got a double mute. Can you hear me?
Yeah, you're good. Okay,
sorry about that. Well, yeah, I just typed it. I mean, I was just wondering if you could speak to the overlap, and I'll claim ignorance if you've talked about this before, or the interaction. You mentioned that your focus right now is urban air mobility, but I assume a lot of the functions and tools and concepts you're coming up with are going to overlap to the other use cases in advanced air mobility. I was just wondering if you could speak to that and how that overlap will be handled through all this.
Yeah, so we prefer to think of it as synergy, right, rather than overlap. So there's plenty of development that's required across these different domains. Each of them have their own unique demands, with urban air mobility, just the close proximity, the compression of the operations is a key challenge. At the same time, the ability to do a contingency landing at a planned site may be, a few minutes away from most locations, where other AAM missions, more regional travel, more traditional aviation operations, you may be, tens of minutes away from that emergency landing site. You may need longer range sensors. So I think the thing, in terms of coordinating and leveraging each other is having a very clear understanding of the requirements for all the applications, and then being able to compare and contrast across those, identifying opportunities to collaborate when it makes sense, and then recognizing when things are divergent. An independent solution is required for that particular mission.
Thank you.
All right. And let's see, we'll move on to the next one here. It looks like, so we got a question from Howard Wiebold. Howard, if you want to go ahead and ask the question that you've got here.
Yes, that's really the question. I was just curious. I mean, anything that flies, the FAA has a say in. So I'm just curious as to what your coordination is with the FAA on your activity.
Yeah, so that's a great question, Howard. And you know, I have to say that I am very impressed with the FAA's proactive engagement across the UAM area. Talking specific to automated flight and contingency management, we are in the process of having a FAA NASA working group to help identify the high priority technologies and the high priority standards that need to be developed to enable that framework for the more flexible certification of both the vehicle from an airworthiness perspective, as well as the pilot from a flight training perspective. We've been having these interactions for over a year at this point, and it's now getting to an officially chartered working group between the two organizations, where it's chartered at the executive level between both government agencies. So it's a very positive development. The FAA is heavily engaged in the national campaign, for example, and is using that to help collect data of interest to them to help accelerate that certification path for vehicles, as well as to help better understand the early flight operations of these vehicles. I just throw that out there as an example of that very productive working relationship.
That sounds excellent. Thank you very much for answering my question.
Sure.
All right, and thanks, Howard, for the question. All right, looks like next we got a question or a comment from Thomas Yeomans. Thomas, go ahead.
Hi, this is Tom Yeomans with Roman Aerospace. We do control systems for drones in the hundreds of pounds range and below 55 pounds. So the question is, right now the RFI is out and there are multiple bullet points in there. And so I'm wondering if for the request for proposal, you kind of have some ideas that you already plan to use, or if you'll really be basing it off of what gets submitted to the RFI.
Yeah, so definitely we're going to look at the RFI from an open-minded perspective, Tom, and to see really what's out there. So I certainly encourage your company to respond to it.
Okay, cool. And do you have a rough idea of when the actual RFP may end up coming out?
Well, so the RFP is that January announcement of collaborative opportunity that I had on that timeline.
Gotcha. Okay.
So look for that in the mid-January timeframe.
Okay, nice. And there'll probably be one RFP with multiple bullet points, then you respond to address those bullet points.
Exactly.
All right. Much appreciated. Thank you.
You're welcome.
Yeah, and I think Ken, maybe clarify a little bit on what is exactly an announcement of collaborative opportunities, because it's not quite an RFP.
So ACO versus right? RFP. Of course, RFP is what industry likes, because that's a request for proposal, and typically the government is putting money out to develop that whatever is requested in the proposal. In ACO, the announcement of collaborative opportunity is looking at more of a in-kind partnership. The general impression or understanding is the technology in this area, there's enough commercial demand out there that companies would see a benefit in collaborating with NASA, just from the perspective of being able to accelerate their development timeline as well as the NASA cooperative aspect is helping to get in place that certification framework that benefits both them as well as the broader community. It's very easy for me to say that as a government person, so I'll request one of the things you might want to respond to from the RFI perspective is just what you think the strengths or limitations of that in-kind partnership approach might be in this area.
All right, that makes sense. Thanks a lot.
All right. Let's see here. So I think let's look at conferences.io and see if we got anything there. Nope. And let's see, it looks like Hervé just added a question in here. Hervé, do you want to jump on and unmute?
Sure, I can ask live. I was just curious. I know it's an RFI, so it's all still TBD. Curious, infrastructure on the NASA side or assets are likely to be leveraged for those activities, or even new infrastructure built or created, and that could be a lot of things, really, from simulator sensing infrastructure, flying platforms, data set collection.
Yeah, so that's a good question. I kind of tried to hint at that, Hervé, at the one chart I had with the picture of facilities. Of course, those are existing facilities. Typically, the big, well, we of course have a combination of lab level simulation facilities as well as the big iron motion base platforms. Those are all part of the planned in-house activities. So there's very much the opportunity to be able to integrate appropriate things that industry might be interested in looking at using those capabilities. In terms of flight assets, that is something that a strategy is evolving there. There's the opportunity to potentially do in-house work using either government aircraft. It wouldn't be an eVTOL, but it would be an appropriate surrogate of some kind, depending on the part of the flight envelope that is being looked at. Could be a fixed-wing airplane, could be a rotorcraft. But of course, all that is going to heavily depend on what aircraft partners might be interested in bringing to the table. I should just mention as an aside, another aspect of the AAM project is another sub-project. It's separate from AFCM, but of course they will collaborate and inform each other. That's the so-called high-density vertiplex sub-project that is looking at using UAS, starting with small UAS, to help do some rapid prototyping exploration of higher volume vertiport, as well as what we're calling vertiplex operations, where, as you might be able to guess, vertiplex means where you have vertiports that are in close enough proximity to each other that they have to be managed as an integrated whole. So the small UAS, from an automation perspective, will begin to implement a lot of the functionality that's also needed on the passenger-sized vehicles. And so I guess if people are interested in that HDV aspect, certainly you could make those interests known on the AFCM RFI, and I can help make sure that information gets passed to the appropriate people.
All right, thanks, Ken, for the response, and thanks, Dr. Hervé, for the question. Let's see, just see if we got any more here. Let's see. All right, I guess I'm not seeing any more questions in the chat here. I guess, Ken, I did have one question of my own. It's a bit more of a technical question, and kind of wondering if you could talk a little bit about how much is the ASCM kind of project diving into kind of sensors and sensing technology, and how much those sorts of things are required to enable the type of autonomy that will be required for this sort of system, or is that something that you're looking for? Is that the type of question that you would want to get out of, say, the RFI, and whether people are interested in that sort of thing?
Yeah, so that's a great question. From our perspective, previous NASA efforts, for example, that we'd want to leverage UAS and the NAS, typically involved partnerships, in particular in the area of airborne sensors to do that detection and perception problem. So looking for industry contributions in that area, industry interest in that area right now is a high area of interest for us. From the AFCM perspective and our in-house work, we'll be looking at integrating the awareness that can come from those sensors. If we don't have appropriate sensors available to us, we'll have to do some sort of modeling assumptions that are appropriate to help flesh out the overall automation suite. Of course, when you say sensors, I guess you're thinking primarily of that broader external awareness rather than the traditional down and in sensors of the vehicle. Although yeah. I should say, even on the vehicle side, being able to do very thorough real-time vehicle health management is another sensing challenge that we would be of interest to us from an RFI perspective.
Got it. Excellent. Thanks. Yeah, no, my question was to deal with the entire breadth of kind of sensing technologies, because like you say, you have the things that are, environment sensing versus internal sensing, and there's a lot to it.
And, looking at the overall UAM system architecture, there's the opportunity to use ground as well as airborne sensors. There's a lot of trade-offs involved there, going back to the question I think Jim asked about comm and connectivity, anything you have on the ground. Of course, you don't have the weight and power constraints, so that's great. But then you also do create this comm dependency. So, we're certainly open to both ground as well as airborne solutions, but have to be aware of how they integrate together as a system.
Sure. All right. Looks like I've got a couple of questions here. One that actually just came in from that I have from one of our NARI folks, just for a clarification here that I'll just bump up here. So if an organization does not respond to the RFI, can they still respond to the ACO?
Yeah, you don't have to do one to participate in the latter, but responding to the RFI gives us better insight into, A, the broader community, and B, your specific interests looking forward to that ACO. So it's an opportunity to help influence what gets included in the ACO.
Sure. Okay. Excellent. Thanks. Let's see. It looks like we got another question from Hervé. And Hervé, I'm just going to ask you to voice it just so it's not just me talking here. I don't know if you want to. There we go.
Hey. Yeah, I don't know if you kind of touched on it a little bit, but just was curious. There are a lot of efforts ongoing at NASA, or things I've been worked on for many years at the different centers are relevant to this. Just curious if some of those groups are already connected or planning to be connected to this on the deep learning side, or design assurance in more generally, or the RTA research. A lot of
in using RTA as runtime assurance rather than required time of arrival, I assume.
Yes.
Okay. Just checking. So sometimes people get those confused. So great question. And, it depends on the maturity of the technologies and what's required to get to the UML4 operating level. So this is an area that we need to do some trade studies. This would be a great area to include industry. My own intuition is that the initial UAM operations, maybe all the way through UML4, we can do that with little or minimum, if any, of the learning algorithms. Of course, learning algorithms are particularly difficult from a certification perspective. So looking at the trade-offs between what is required for initial and medium-term operations, getting into longer-term operations where those adaptive algorithms probably become important. I should mention that with that automation working group that we're standing up with the FAA, there's basically two objectives within its charter. One is specifically looking at accelerating the path to UML4, and then the other objective is specifically looking at approaches to certification of adaptive algorithms. You specifically called out runtime assurance. That probably is one of those near-term things that provides us a way of using some more complex algorithms to do more strategic functions that may be important from a operational efficiency perspective, but can be backstopped by simpler algorithms in that assurance wrapper that maintain safety of flight. So definitely evaluating the application and compatibility of runtime assurance to near and midterm UAM operations is a priority to us.
Maybe just to clarify, my point is maybe not to focus on those specifics as just the latest off the top of my head that I think of, but I know there's tons of work that's being done on autonomy and automation generally. So
yeah, so I mean, of course, leveraging those activities from around the agency, the system-wide safety program is the current home for a lot of the researchers that either did those previous activities of interest to you and are working on current things. They're integrated into the overall UAM mission across the agency. So certainly trying to take advantage of that expertise where it exists.
All right, excellent, thanks. Eve, did you have a follow-up on that or no?
No, I just thank you for the answer.
Sure.
Okay, gotcha. And looks like let's see, Howard Bebold looks like you've got another question here.
Yeah,
so
yes.
Go for it.
Yeah, thank you very much. And I'm with Honeywell. I forgot to mention that earlier. So the ACO result will be a Space Act agreement rather than like a CAN. Is that correct?
Space, and it'll be appropriate to whatever sort of partnership is desired. I believe the agreements for the national campaign have been Space Act agreements. You'll actually have to educate me, Howard, on what the CAN acronym stands for.
It's a cooperative agreement notice. We've had a couple of CANs with NASA previously in our detect and avoid work.
Okay.
And I was just trying to make a separation between the Space Act, as I know, as I think, is purely we both agree that we're going to go do some work together. I'll spend my money, you spend yours, but we work together. Whereas a CAN can actually involve funding from NASA and matching with in-kind and or cash cost share from industry. So I was just trying to make a distinction between what the end result might be. And it sounds like you're open to almost any.
We're open, and that's where I rely on the lawyers to work the details of what's needed for the two organizations, as to how they want to work together. I'll certainly say that there's a desire to have in-kind partnerships as opposed to funded partnerships.
Thank you.
Sure.
And all right, thanks, Howard, for the question. Let's see, we have anything on conference? Looks like don't see anything on conferences.io. So it looks like we're running out of questions here. I'm going to give people just another minute here in case anybody wants to add something into the chat here. Let's see. I guess I'll take this opportunity. I had a request from PK to give a quick announcement on a meeting for next week. So the AAM supply chain working group will be kicking off next Thursday, which is August 13th. And PK says we encourage OEMs and subsystem providers to join that working group and the kickoff. And I assume that the information for that is on the NARI website, which is up here on the screen. So that's just a quick plug for our meeting that's going on next week. Let's see, and I guess I'm not seeing anything else on the chat here, so I think we'll go ahead and kind of wrap things up and just give people a little bit of their Friday afternoon back to get ready for the weekend. So I will just say the next aircraft working group meeting will be August 27th, which I believe is a Thursday. That is going to be the topic that we actually originally had planned for last week, but we decided we wanted some more time to put together the discussion on that one. So that will be on passenger acceptance and ride quality, which actually ties in with automated flight and contingency management in that we have to know how passengers accept automated flight. It's a bit of a question there. Let's see, just for people's benefit and points of contact if you need to get in touch with those of us organizing the working group. So Brianne Stallsmith is our NARI coordinator, and I'm the technical point of contact for this working group. So if you want to get in touch, you can email either of us. Ken, I don't think we stuck your email address on here. If people want to get in touch specifically about the RFI, you can shout it out if you want to. Or
yeah, sure. I think it's easy to find online, but just K.Goodrich at nasa.gov. Okay. And Carl, closing statements here. Let me sure. give thanks to the participants today. I enjoyed the interaction. Don't hesitate to email directly if you want to continue. And of course, there is the RFI to have official response. Carl, let me thank you for being a very good moderator for today's discussion, and also thanks to the NARI staff for the smooth facilitation of the meeting. So thank you all.
Absolutely. I thought this went really well, and I think the numbers that Anna texted me was we had about 70 people watching on YouTube and about 50 people on Teams here, so about 120 folks tuned in. So good turnout. Thanks everybody for joining us on your Friday. I think that's all that I have. Ken, unless you got anything else?
No, I'm good. Thank you, Carl.
All right, excellent. Well, thanks everybody for attending, and have a wonderful weekend.
Bye-bye.
Thank you. Stay safe.